So this is our first topic for current electricity. We're going to look at our introduction to current electricity and circuit diagrams and how do we draw circuits on paper, because they can get pretty complicated, so we want to make sure that everything's nice and organized. So let's go through what current electricity is, and then I'll show you some symbols for drawing circuit diagrams. Okay, so first off, what is current electricity? Current electricity, or circuits, is produced by the continuous flow of electrons in a circuit. So remember, when we studied statics and when we studied chemistry, we actually looked at how only electrons can move and protons and neutrons can't move. So what happens in current electricity is that the electrons end up actually moving through wires and making circuits. So an electric circuit is used to convert electrical energy from the electrons to another usable form of energy. So here are some examples of that. So sometimes we convert electrical energy into light energy to turn on the lights of our house or in the class or anything like that. The other thing we use electricity for is to transfer it to mechanical energy. So you've all heard of an electric motor before. You might have examples of this at home, maybe in your lawnmower. Maybe some of you even have electrically powered cars or hybrid cars. So that's basically what's happening, is we're taking the energy from these electrons in a circuit and we're converting them to another usable form of energy. All right, so now the parts of an electric circuit. All electrical circuits have four basic parts, so you need to know what these are. The first part is a source of electrical energy. So examples of this are a cell or a battery or an outlet. So there has to be some place where the electricity comes from. The second thing is an electrical load. And this is a device that will take the electrical energy from the source and convert it into another usable form of energy. So a really common example of this is a light bulb. Another example is a motor, or if we look at a toaster, it'll actually take some electricity and convert it to heat to toast your toast in the morning. All right. Third part of an electric circuit, it must have a control device, and this determines if the circuit is open or closed, or if it's on or off. So a really good example of this is a switch, just like a light switch when you walk into a room. To close the circuit and turn it on, you flick the switch. To close or to open the circuit and turn it off, you turn the switch off. And the last part of a circuit, connectors. In order to put all these things together, it provides a controlled path for the current or for the electrons, and therefore must be a really good conductor of these electrons so that the electrons can move through it. So examples that we will most commonly use are copper wires. All right, I talked really quickly just now about the difference between an open and a closed circuit. So let's actually put this into your notes so you have this to study from later on. So a closed circuit is basically a working or an operating circuit. That means the current can be flowing through every part of the circuit, and the switch or the control device must be closed. So when a switch is closed, the circuit is on. An open circuit is a circuit that is not working or not operating. Therefore, the current is not flowing through every part of the circuit. And the circuit has some sort of a break in it. Okay? So this usually happens with the switch. So when the switch is open, it sort of breaks the circuit apart, and the current cannot flow through, and you have something that is not working or not on. So that's the difference between your open and your closed circuit. Oops. Okay, so now the next part is, okay, we know what a circuit is, kind of. How are we going to be able to draw them? So the first thing we have to be able to draw are the electric sources. When we do this, we have to indicate the positive and the negative terminals. Just like a battery has a positive and a negative terminal, all these sources have positive and negative terminals. So you might have a 1.5 volt cell or a 3 volt battery or a 6 volt battery or a 9 volt battery or a variable power source. So when you are doing these, you have to make sure that you're drawing your symbols correctly and they actually add up to the correct number of volts. So I know you guys don't fully know what a volt is, but hopefully using this you'll be able to figure it out. So the first thing, okay. So the first thing is a 1.5 volt cell. So a 1.5 volt cell has a short line and then a long line. Or you could write it horizontally, short line and a long line. Regardless of the way you write it, the shorter part is the negative part of the cell and the longer part is the positive part of the cell. Okay, so that is sort of one pair, and they always have to come together in pairs. So you always draw a short line and a larger line in a pair. To do a 3-volt battery then, you'd have to add two 1.5s together. So if I have 1.5 plus 1.5, that equals 3. So that means I have to draw one 1.5 volt battery or cell and another one. So you have these alternating short and long lines, okay? And again, your negative is always the smaller line and your positive side always has the longer line. Okay, so now can you draw a 6-volt battery? Well, a 6-volt battery has to be 1.5 plus 1.5 plus 1.5 plus 1.5, and that gives you your 6 volts. So I have to basically draw 4 of those cells back to back. So here's 1, 2, 3, 4. That gives me a 6-volt battery. All right, and hopefully you can figure out what a 9-volt battery would look like. So there's 3, 6, 9. Okay, so the larger the voltage, the more lines you have to draw. All right, so now to do a variable power source, all I want you guys to do for this is to draw me, I usually draw like 3, and then what you actually have to draw underneath or on top of it is how many volts it is. So if this is going to be 5 volts, then you write 5V underneath it. So that tells me that even though it looks like it shouldn't be a 5-volt battery, because you wrote that, that's basically how we're going to draw the variable power source. All right. Next up, how do we draw a light bulb? Now, I think you guys have seen throughout the semester that my drawings really suck. So a light bulb is basically a circle with a squiggly line through it. That's it. So that's our symbol for a light bulb. Our symbol for a motor is pretty easy. It's again a circle, but it has an M in the middle. And then it'll be connected by wires. And then a resistor is basically a sideways S. So sort of 2 dots there. So these are some of the loads that you're going to be seeing. Oh my. Okay. And then there's also some meters, okay? So an ammeter is going to measure the current. Oh, hold on. My smartboard just disconnected. Oh, shoot. Great. No, my smartboard just disconnected. Okay, so you guys can just write this in maybe. I'll try and disconnect it and reconnect it again. So, your ammeter, your symbol for your ammeter. Sorry, guys. There we go. Oh, now we're in business again. Yay! So a symbol for an ammeter is a circle with an A in the middle. And I just lost my thing again. And the symbol for a voltmeter, oh, there we go. And your symbol for a voltmeter is a circle with a V in it. So that's actually quite easy to remember. So now all we need to know is what do these things measure, okay? So An ammeter is going to measure current. And your voltmeter is going to measure potential. And we're going to talk more about what this means later on. So for now, that's all you need to know. I just want you to know your symbols really well. And then the last thing, connectors. So to draw connecting wires, basically we just draw a line. Okay, wires that are connected are usually connected with a dot, sort of like that. And then if you connect something to a ground, you have to basically, so let's say I've got, here's a circuit, and I want to connect it to a ground. The ground has progressively smaller lines, just like that. Okay, or I could draw it, if you wanted to, I could draw it coming up this way. And you've sort of seen that when we did charging by induction earlier on. That's basically it. Oh, sorry, nope. A few more control devices. A closed switch. Looks like this. Okay, and the two dots show that it's closed. If the switch is open, it looks like this to show that it's open. And the last thing is a fuse. Oh, you know what? I made a mistake. I'll fix that now. So your fuse is at curved S. And I'm just going to go back. So once you guys have that copied down, I'm going to go back to my resistor over here. I apologize, guys. Your resistor doesn't look like that. So if you can erase that or cross it out, your resistor looks like a zigzag line. That's a resistor. Okay, so let's go through a couple of these examples. Can you draw this in the form of a circuit? So can you draw a 6-volt battery, a switch, a light bulb, but the light has to be off. So if you want to try drawing that, you can pause it and then restart the video, because I'm going to go through the answer right away. So first off, the 6-volt battery looks like this. So now we have to connect that battery together. Okay, we have to include a switch. So you can put a switch wherever you'd like. I'll put the switch here. We need a light bulb. So here's my little light bulb. And the light has to be off. That means the switch has to be open. Okay, if we drew that switch closed, then the electricity would be able to flow through and you'd have a light bulb that's on. All right, let's try this one. A 9-volt battery, a motor, a switch, an ammeter, with a negative terminal connected to the negative terminal of the battery, and the motor is running, so that means the circuit has to be connected. Do this one in blue. So a 9-volt battery looks like that. We need a motor, so I'll put the motor over here. We need a switch. I'm going to put the switch on. And we need an ammeter where the negative terminal is connected to the negative terminal of the battery and the motor is running. So this one is actually complicated, and we're going to talk about why this one is after. But we need to do basically is stick an ammeter in here, okay? And the negative terminal of the ammeter is going to be connected to the negative terminal of the battery. So it'll look something like that. So that's basically how we draw circuits. We'll do some more examples of it in class and get you guys to build some.